Hey guys, what's going on? Today we are going to take a look at some of the different fiber testing tools that are available from our vendors and how they relate to helping out our clients. So here we've got a network. Here's our CO. This would be coming from our network provider, and they're transmitting light to our house over here, our subscriber. And we have a couple different tools to use to try to solve any customer issues they may be having. So this person calls up and says, hey, every time I try to stream my college professor, it gets all pixelated and it lags and I miss so much of the content. So these guys get that phone call and they're like, oh, what are we going to do? All right, so I want to go over some of the basic tools to try to help this customer out. So the single most basic tool is a VFL, Visual Fault Locator. It's a fancy word for a red flashlight. It's just a powerful red flashlight. That is it. So it's about the size of a marker. You can have them where they're the size of a marker, and you connect it to a singular fiber, and that fiber lights up red. We also can spec them out on OTDRs. Right here, we have this little port, and that port will shoot red light through it. It'll connect right to a SCAPC connector or whatever connector you really need. So what is that red light used for? Well, this strand of fiber going from the CO to that house, this might be a 144 count fiber. And they might be confused of, you know what, something doesn't look right. This is supposed to be a red colored fiber over here. It's blue. This might be why we don't have internet. So what they could do is take that red light, and the technician that's here on site, he could plug that in and it'll go blasting down through our fiber cable. And some of them will shoot 5 miles and some of them will shoot 30 miles. You can get these VFLs to have different power. So if it's a keychain one with a singular battery, it's not going to shoot very far. But regardless, we shoot that red light down this fiber cable, and if red light shows up here at the head end, a technician's going to say, oh, yep, this is definitely it. I see the red light. Another really cool thing with the red light, so it acts as a continuity tester of we're on the right path and the path goes all the way to where it's supposed to go. The second thing is when you get a bend in a fiber cable like this, the red light will actually leak out a little bit and you'll be able to see the red light. Now that's usually more on jumpers or pigtails or inside of a splice case, not usually through that thick black jacket. So Visual Fault Locator, super cheap tool, very easy way to solve some very simple, maybe confusing problems just by verifying continuity that what you think from point A to point B is the right path of fiber. The second one, and this is what a lot of technicians are outfitted with, a power meter. It is small. I don't have one with me, but it's about the size of a phone. So they go out to the customer's house and they verify how much light is right here. It's just metering how much light it is receiving. So there's any given network has a light link loss budget, and they'll decide how much power needs to be injected into the network, and then they'll figure out how many connectors at a patch panel, how many splices or splitters are in a network, how much loss might be associated with it. And they'll calculate that if this is in good shape, that once we get to this house, we're at 18 decibel, okay? That means we would have a happy customer because this ONT only accepts a certain amount of light. We got another video that kind of explains that concept in a little bit more detail, so check it out. The power level for this ONT is 15 to 25 decibel. So if this customer calls up and says, my internet's out, come fix this, what is going on? Our customers may or may not need a potentially $12,000 piece of equipment. they might only need a couple $100 piece of equipment to help with this problem. So they could send a technician out on site, drive this 5 miles to the customer's house. They unplug the cable from the ONT and they connect their power meter right here. And that power meter is simply going to tell them what the light level is. It's going to tell them if they're at 18 decibel or if they're at 14 decibel. At least they know. It's a way for them to verify how big of an issue this is and whether or not it's a plant issue, which is the world we live in with cables and handholds. That's an outside plant issue. But if that technician comes here and they use that power meter and it says that the light level's at 18 like the engineers designed it to be, all right, guess what? That's an inside plant problem. It's probably an issue with the electronics. And it's cats and dogs when it comes to our network providers, where outside plant and inside plant technicians often are always blaming each other. So this power meter is a great tool to separate. Is this an inside plant or outside plant related issue? And also, if you have a number that's super close, let's say you're at 14 decibel, that technician, he's going to try to clean that connector right away. He's going to look at the routing in that NID, and then he's going to measure the power again, and you might be like, perfect, there we go, I gained a dB. We're good. We're at 16, it works, because we're within this ONT's window. All right, so those are very two inexpensive tools that most technicians should be outfitted with. Now, OTDRs and OLTS testers. So we spend a lot of time talking about OTDRs. And OTDR is a great tool. What they're used for is troubleshooting. So it is going to be a great tool for verifying where elements in your network might be, like this connector or this handhole or where your splice and splitter is, but it's also going to find troubles within your network. Like here, we found that there is a bend in our cable because 1550 had a loss, 1310 did not. An OTDR is going to be able to find that event. So it's a troubleshooting tool to quickly identify where and what an issue is. Primarily, the people that are using OTDRs are going to be our network providers, our service providers. This is one of their number one tools. Contractors use them as well. But what happens is our network owners, they might decide, hey, we've got a huge project. We're not going to do this project ourselves. We need to hire somebody. We need a contractor to come in-house. And then the contractor sends them the bill, and they're like, ooh, wow, that's expensive. So they make this huge investment in contractors building their network. How do these network owners know if these contractors did a good job or a bad job? Were they just trying to get this 5 miles of cable installed as quick as they could, and maybe there's a ton of bends in the cable? Maybe they stretched it. Maybe they used their mini excavator to pull it in and exceeded the 600 pounds of tensile strength. They don't know. They're not watching every single move these contractors are making. So a lot of network owners, if they have contractors come do their work, they're going to require OLTS testing. A lot of time with OLTS testing, and that's optical loss testing, that is very commonly done. You might hear the words like BiDi, bidirectional testing. And with OLTS testing, this is the only way to measure performance. It's the only way to measure. An OTDR, all it's doing is estimating what the loss is from here to here. It's estimating. So if I were to run across this room right now as fast as I can, I get to the other side and be like, wow, that was pretty fast. That was really good. But that doesn't mean anything. That was my own judgment. That maybe it's a good judgment, could be a bad judgment too. It's an estimate. The only way to know if I was really fast running across this room is to use a stopwatch. Time myself across this room of, I got to cross this room in 3 seconds. I am fast. So the Oltz meter is basically that stopwatch. It is going to tell us the true loss in a network. It is not going to be a great tool for a network owner to own themselves because it's not necessarily good at identifying where an issue is. Okay? A lot of times it's with our contractors that are using this tool. So how does an Oltz meter work? Very briefly, no matter what, when you're doing Oltz testing, you have to have 2 Oltz testers. And that's why it's called bidirectional testing. So we send a technician out to this house. They're holding their Oltz meter. And with Expo, these are called 945s. We send a technician out to that house. And we have a technician over here at the head end. And they're also holding a 945. So they connect to this cable and they shoot a spitball down this fiber. And they inject 40 decibels of power into that. And they know the engineer designed it at 18 decibels. So when that technician goes to this house, the only number that should be seen is 18. If it's seen a different number, that contractor did something wrong. Maybe they didn't do something, like put in a splice, or maybe they did a really bad job, like accidentally bending the cable. It is the only way to verify that the work done between the CO and between the house was done within the standards the engineers set with their light budget. So you have to have 2, and that is why we call it bidirectional testing. And each unit is sending and receiving spitballs at the same time. So this machine is sending spitballs and sending them out at a pre-described power, but it's also receiving spitballs and quantifying them. It's verifying how much that spitball is receiving at the same time. Same thing is happening over here. It's both sending and receiving spitballs and measuring them. Some people get confused because you can order a power or a 945 and it's a light source power meter essentially. This standalone unit is a light source power meter in itself. But you can also order this with a separate power meter. So the separate power meter right here is used for that one technician who goes and just wants to see what the light level is to verify if it's outside plant or inside plant. So don't get those confused. A power meter cannot necessarily do bidirectional testing, not efficiently at least. So Oltz testers are hands down the best product on the market to verify what the true measurement is within a network. Now, one lesson before we go, which means I'll probably have 3 more things, is that there's a lot of different forms and functions to OTDRs and Oltz meters. Max testers. This is the max tester right here, right? It's heavy-duty rubberized device. Is this an OTDR or an Oltz tester? I don't really know unless I look at it closely enough and see a model number on here. Because a max tester can be an OTDR or it can be an Oltz meter or it can be a WDM tester. These things can do a lot of different testing. The max tester is a body that holds set hardware inside of it. So when a customer orders a max tester and they decide that they want this to be an OTDR. Let's say a 720 OTDR. This will always be a 720 OTDR. We'll never be able to have it be an OLTS tester or a WDM tester or whichever type of testing comes out in another 5 years, or whichever is the next oddball project somebody gets called onto. So a max tester, it can be an OTDR or an OLTS meter when it's created at the factory. After that, this is set in stone. You're not changing this. The other route we can go is a platform. So this is a Exfil platform, and this is basically a really expensive Nintendo, and we can put different games in it. These are called modules, and we can put different video games in it. This video game is an OTDR. This is a 750 module for doing long-haul OTDR testing. But if I'm a contractor, or even a network owner for that case, is I can say, all right, we need this OTDR on this project. But then the next project comes along, or a different type of issue comes along, and instead of having to buy a whole nother max tester, you can take out your video game and buy another video game. And this one is a 945 OLTS tester. So you can now plug this video game into a platform. There's a lot of confusion within the marketplace on what the difference between a max tester is and what a module OTDR platform might be there. There's just a lot of confusion out there. A max tester, you order from the factory, and it can be an OTDR OLTS tester, but once it is created, you're set in stone. You can't really upgrade this, only software upgrades. You order a platform and a module. This is always going to be future-proof, more upgradable. You can have these platforms where you can put in multiple video games at once if you want. And that might happen where this person, they're doing this OLTS testing, sending spitballs to this guy, and this guy goes and hops in his truck to go to the next house. Meanwhile, this guy turns on his OTDR video game and does an OTDR trace on here as well. So these are a very flexible platform. The initial investment, if we go apples to apples of here's a platform with an OTDR, this is going to be a couple grand more than going with a max tester OTDR. Hope this helps you advise your client a little bit or help you understand some of the testing products in the marketplace. Feel free to reach out to our team with any questions.